addition of sodium bisulfite to carbonyl compounds. This is today's lesson. Let us see structure formula of sodium bisulfite. Sodium bisulfite or sodium hydrogen sulfide. Structural formula is sulfur, oxygen with negative charge, sodium with positive charge. Here oxygen, hydrogen, sodium bisulfite. This is structural formula of sodium bisulfite. Here sulfur carries free pair of electrons in this way. Sulfur 16, atomic number 16. Electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p4. In the outermost shell of sulfur, there are 6 electrons. Out of the 6 electrons in sodium bisulfite, sulfur used 4 electrons, 2, 3, 4. So 2 more electrons are left that remain as free pair of electrons. Because of these free electrons, sodium bisulfite acts as nucleophile. Sodium bisulfite acts as nucleophile because of these 2 free electrons. Now let's see the general process of addition of sodium bisulfite to carbonyl compounds. Carbonyl compounds. This is functional group of carbonyl compounds which is added to sodium hydrogen sulfide. Let us write simply, this is electrophile and this is nucleophile. Nucleophile combines with positively charged carbon. Electrophile combines with negatively charged oxygen. Electronegativity of oxygen is higher than carbon. That is why pi bonded electrons move towards oxygen. Oxygen becomes negative in charge, carbon becomes positive in charge. That is why nucleophile combines with positively charged carbon. Electrophile combines with negatively charged oxygen. Ultimately, this is found oxygen with hydrogen. Oxygen gets this hydrogen. With this carbon, SO3, sodium. Carbonyl compound sodium bisulfite. General process of addition of sodium bisulfite to carbonyl compounds. The additive product is carbonyl compound sodium bisulfite, which is white crystalline solid that gets separated from the reaction system. That is why this reaction is used to separate carbonyl compounds from other organic compounds. This is the importance of the reaction. Now let's see some reactions of addition of sodium bisulfite to carbonyl compounds. Carbonyl compound, for example, acetaldehyde or ethanol, which is treated with sodium bisulfite. proton, sodium sulfite ion. This combines with positively charged carbon. Proton combines with negatively charged oxygen. As a result, this is obtained. This is ethanol sodium bisulfite, which is white crystalline solid. Another reaction, propanone sodium bisulfite, electrophile, nucleophile. Nucleophile combines with positively charged carbon. Electrophile combines with negatively charged oxygen. Ultimately, this is found. This is propanone sodium bisulfite, white crystalline solid. Another reaction, benzaldehyde sodium hydrogen sulfite, proton sodium sulfite ion. Nucleophile combines with positively charged carbon. Electrophile combines with negatively charged oxygen. Ultimately, this is found. Benzaldehyde sodium bisulfite. Let us see another reaction. Benzophenone or diphenyl ketone, sodium hydrogen sulfite. Here, two bulky groups, phenyl groups. These two phenyl groups create steric hindrance. That is why carbonyl group remains free from the attack of electrophile and nucleophile because of the special hindrance of two bulky groups, phenyl groups. That is why in this case no reaction takes place. Now let us see mechanism of the reaction. Simply we have seen sodium bisulfite in this way, proton sodium sulfite ion. Now let us see the actual mechanism of the reaction. Suppose this is carbonyl compound functional group. This is ionized in this way. Oxygen becomes negative in charge, carbon becomes positive in charge. This is step number 1. Step 2, sodium bisulfite. Structure formula. Sulfur carries free pair of electrons. Functional group of carbonyl compounds. Sulfur attacks the positively charged carbon of carbonyl compounds through donation of these pair of electrons. Now this is formed. Oxygen becomes negatively charged. With carbon, sulfur forms bond with carbon in this way. Sulfur forms bond with carbon, with sulfur, oxygen, sodium, with sulfur, oxygen, hydrogen, again with sulfur, this oxygen with sulfur, oxygen double bond. Now sulfur here donated this pair of electrons to carbon. That is why over sulfur positive charge is developed. Because of this positive charge, oxygen hydrogen covalent bond shifts here to form sulfur oxygen double bond. Now this is formed. Oxygen, sulfur, sulfur oxygen double bond, sulfur oxygen double bond, and this hydrogen gets freed as proton. This proton combines with this oxygen. Now this oxygen converts to hydroxyl group. Here oxygen sulfur double bond, sulfur oxygen double bond, oxygen negative charge, sodium positive charge. With this sulfur there is another oxygen. This is the mechanism by which addition of sodium sulfide to carbonyl compounds occurs. Simply we can write OH, here sulfur carbon bond, sulfur, oxygen 3, then sodium, carbonyl compound, sodium bisulfite. This is the mechanism of the reaction. Through this mechanism, carbonyl compounds react with sodium bisulfite to form white crystalline solid carbonyl compounds, sodium bisulfite. Following these two steps, the reaction is completed. Number today, thank you very much.